Good afternoon, everyone. It's my pleasure to introduce our last speaker today, Jeffrey Bridge from Blue Origin. He will talk about their big dreams today. So Jeffrey completed his undergrad studies at Rice ECE in 2011. His senior design project of an autopiloted UAV with Team Electric won first place in the TI annual design contest. And then he has been working full-time at Blue Origin since 2012 on their reusable vertical takeoff, vertical landing new Shepard suborbital rocket system. In 2005, this vehicle became the world's first booster to successfully complete a powered vertical landing after coming back from the space. Jeffrey works on the sensor and actuator interface, power system, flight safety, harnessing, radio communication, testing, and flight operations of this. Let's welcome Jeffrey.
Thank you. Good afternoon. Thanks for having me here. My slides today are going to be a little bit different. I'm just going to give an overview of what Blue Origin is doing, and then I'm going to try to leave plenty of time at the end for questions. So as some of you may know, Blue Origin is a small aerospace company founded by Jeff Bezos, who is the founder and CEO of Amazon.com, a little company. We're a little different than most other aerospace companies in that we not only design, build, test, and fly our own space vehicles, but also the engines that power those vehicles. We want to see millions of people living and working in space. Our motto at Blue Origin is Gradatum Ferociter, which means step by step ferociously in Latin. Currently, we're focused on developing vehicles and technologies that lower the cost and increase the reliability and safety of human spaceflight. Our goal is to develop well-understood systems, including vertical takeoff, vertical landing vehicles that can be recovered and reused. We do that by taking an incremental approach in developing larger and more powerful vehicles that can reach further into space. We're currently working on two vehicles, the new Shepard system, which is on the left, which is a suborbital vehicle, and then on an orbital vehicle called New Glenn on the right. The new Shepard system is in flight test phase. It is a reusable space vehicle that will take people and payloads to suborbital space and back. We've had 10 successful flights in a row across multiple boosters, and we've also taken customer payloads up at this point. And we hope to have our first human flight this year. The vehicle is designed to take off vertically and land vertically. It's powered by a single rocket engine with a thrust of 110,000 pounds, powered by liquid oxygen, liquid hydrogen. That engine is called the BE3 for Blue Engine number 3. The crew capsule, which is on top of the booster, is designed to seat 6 astronauts, or you can take the seats out and exchange the seats for payload racks instead. The propulsion module, or booster, has fins and brakes that enhance its aerodynamic stability and slow the vehicle down for a gentle landing. The ring fin, located at the top of the booster, shifts the center of pressure on the way down by allowing airflow through the opening. There are 4 wedge fins that come out also at the forward end for stability. And then drag brakes are deployed during reentry to drop the speed of the vehicle by about 50%. At that point, the engine turns back on again and burns off most of the velocity, bringing the vehicle down to about under 5 miles an hour before the landing gear come out, and then it comes to a soft touchdown on a pad. This video here shows a compilation of all of our test flights of New Shepard to date. just going to pause here and see if I can get the audio to work. Nope. Sure.
Is it your laptop?
Yes, it's mine.
This might be the audio.
Yeah, it's,
And it should have it.
okay. All right. It worked this morning.
Yeah. Audio
Summer. Yeah.
We are using HDMI.
Yeah. Yep. So we're currently looking at the third flight here where we reflew the booster after having landed it successfully. This is our fourth flight where we tested a lower restart altitude on the engine. Fifth flight where we tested a test case where one of the parachutes doesn't come out on the capsule to verify that it's still safe for landing under that condition. Sixth flight where we actually did an escape in flight at the maximum dynamic pressure. Booster continued up to space and back down successfully. First flight of a next booster in the series and a new capsule which has windows, as you can see. Great question. Can I come back to that at the end? This flight is from the middle of last summer or so. This was going all the way up to 350,000 feet. See a little bit of zero-G footage there. Ping pong balls bouncing off the window. And this was our third escape test where we tested an escape right at the point where the engine cuts off, so very high altitude, which is a stressing case for the escape system. All right, so what will the flight look like for astronauts? So we can have up to 6 astronauts in the crew capsule, and they'll get to enjoy about 4 minutes of microgravity and the largest windows in space. The crew capsule is equipped with a full envelope escape system, which you saw a couple of those tests for, but it's designed to land nominally under parachutes. We've got another video here showing off some features of the crew capsule. You can see the crew hatch. You can see the interior with the padded walls, because you know, once you get up and unstrap out of your seat for those 4 minutes, you might bump around a little bit. You'll have a large panoramic view of the curved Earth horizon below you. And we have seats that are specially designed to absorb the impact of landing to provide a gentle experience for the passengers. Okay, and then the next video here shows the view from inside the crew capsule on one of our test flights. We have an instrumented mannequin, much like you see in car safety testing, which has internal sensors to measure forces on the neck and all that kind of stuff to make sure that we're meeting all the safety and non-injury requirements for passengers. There'll be sort of a slow rotation around so you can see all around the Earth while you're up high. And then it's starting to come down back into the atmosphere again. little bit of gentle aerodynamics going on. And then here we're under the main parachutes for the last few thousand feet before you touch down gently on the ground. Now you're back on Earth.
How much does it cost?
Good question. I'll answer that at the end. Yes. If you're an Amazon Prime member, you might get a discount. So New Glenn is the next step in our vehicle development. This is a much larger vehicle. It's over 300 feet tall. It will be manufactured at our facility in Florida, and it's going to be powered by our BE4 engine. That's a rendering of what it will look like in flight. And here is a brief video of our manufacturing facility in Florida. So large pieces of metal go in on the left, and completed rockets come out on the right. So this is a picture of our BE4 engine. This engine runs on liquid oxygen and liquid natural gas, which is mostly methane. And it has a thrust level of 550,000 pounds. It runs on a unique oxygen-rich staged combustion cycle, which is something that up until this point in history has only been done by certain Russian engines. It's designed for up to 100 reuses of the engine, so we can keep reflying these engines over and over again, much like you do on a commercial airliner. This engine has been designed and built, and we're in the process of testing it at our facility in West Texas. I have a video of it test firing, which I'm very sorry that we don't have the audio for, but just imagine a loud engine roar here. Frankly, I'm not quite sure how the drone survived being in the air with all that acoustic vibration. So our BE3U engine is an upper stage version of the LOX LH2 engine, which powers the new Shepard booster. It has a much larger nozzle to operate at a higher efficiency in a vacuum. And this engine will be powering the upper stage of the New Glenn launcher. A little sneak peek, we're working on concepts for a lunar lander platform designed to take payloads down to land on the surface of the moon. This is something that NASA is very interested in doing as part of their Return to the Moon program, taking some scientific packages down first as sort of a preliminary step towards landing people again. This slide is already a little bit out of date. There's now almost 2,000 of us, I think, at facilities all across the country. Our main headquarters in Kent, Washington is where we do most of the design and manufacturing and small-scale testing. We have our launch site in Florida as well as manufacturing center there for the New Glenn vehicle. And right here in Texas, we have our large engine test stands for the BE3 and BE4, as well as that is where we launched the new Shepard vehicle. And we also just broke ground on a new facility in Huntsville where we're going to be manufacturing BE4 engines. So some of you might be curious about opportunities for internships and full-time employment at Blue Origin. We have a year-round internship program with opportunities in the fall, spring, and summer. And housing costs is included. For people who are graduated, there's a great program where you can come on and rotate through 3 different engineering projects in different groups in your first year and find something that suits you. If you have any questions afterwards, I'm happy to answer any and all after the talk's over. So if you really want to know what it's like to work at Blue Origin, we released this video of our engineers in Kent watching in real time the first successful launch and landing of New Shepard in late 2015. So you can see the long-range tracking videos on the bottom showing the capsule on the left, probably, I think, and the booster on the right. And they called out that the drive brakes deployed. That was a major milestone in the flight. And then the engine is relighting. It's a very big moment. And then the landing gear is starting to come out. And you can see it's not going to hit the ground. This was our second flight of New Shepard, and it was the first successful landing. And then the engine shuts off, the vehicle's still upright, and there's much rejoicing. I have some great coworkers. So thank you very much for having me here, and I'll open it up to questions.
We already have the 2 questions you didn't answer.
Yes. So
Please start with
please remind me of the first one.
vertical. Why
Yes, vertical. Why vertical? So it's true that both ways you only get one chance to land, whether you're gliding in under no power or vertical. But the difference is a winged vehicle is harder to scale up to larger sizes, whereas vertical landing gets easier the larger the vehicle is. And since our long-term goal is to have very large vehicles to reduce the overall cost, it makes sense to start with a small vertical landing vehicle and then take that technology and scale it up. And second question was about the cost. So we have not set a ticket price yet. One of our competitors has been selling tickets for a decade now for $250,000, and they haven't actually sent anyone yet. Some people are asking for their money back. But as soon as we, I think, have our first human flight, we'll probably put a cost number out there. I imagine it'll be similar to what our competitor is charging.
So,
Yes.
So how many G's going up?
I don't remember the exact figure, but it's no more than 3. We have the ability to throttle the engine to G limit for passenger comfort, much like the space shuttle does, for instance.
So spacesuits going up?
No spacesuits. This will be a short sleeves cabin. Yeah, so we don't want people who are about to have a heart attack. But we're aiming to eventually be able to accommodate a wide range of body sizes and ages.
What's it talk about some of the things you do to refresh the system to go back up again, and how much does that cost to turn it back over?
So initially a lot of the challenges we had were with the thermal protection material. It looks pretty charred after each flight, and it took a lot of work to refurbish that. So we've done a lot of work on trying out different thermal protection materials to make that quicker turnaround. I can't give you a cost figure.
So on the rocket descent, it's free falling to Earth. How many seconds before impact does the rocket come on, and what speed is it going when the rocket turns on?
So the descent rate is about 350 miles an hour, and it's probably about 20 seconds from impact if the engine weren't to turn on at that point.
Hi, maybe I'm next. Blue Origin, I thought you guys were just suborbital. So why buy land in Florida? Because you don't really care where you take off for if you're not going to go into orbit, right? I'm not a rocket scientist, but that's what I always understood.
Yeah, so great question. The suborbital vehicle, Mercury Redstone back in the 60s, they launched from Florida, went out over the Atlantic, parabolic trajectory, land 100, 300 miles downrange. Because we're aiming to not have to deal with water recovery, we go very nearly straight up and straight down. The booster lands about 2 miles away from where it started, having gone 65 miles up and 65 miles down. For the orbital vehicle, you really need to launch over water for safety reasons, because to get to orbit, you necessarily must go sideways, and you don't want to do that over populated areas. The bigger one is an orbital vehicle, that's right. New Glenn is the orbital vehicle.
So the previous talk actually has a really interesting synergy with yours, because you talked about this device versus drug difference, and there's this idea of taking a technology in its sort of minimal viable form and bringing it to market as a way of gaining revenue streams that then would allow you to develop the more exciting things.
Yes.
So I know that there's been some recent announcements from the military about their sort of long-term contract strategies for orbital vehicles. So I'm curious, to what extent is space like medical devices where government funding is really required, and to what extent is it something where R&D is really sustainable in the private sector? Great
question. As you may be aware, our founder does have pretty deep pockets. And he tends to think in terms of very long timelines. He's very interested in making this a profitable business. I don't know if you've seen any of the news, but we were selected in the first round of the Government Launch Services Agreement contracts. And the second round of that is coming up soon. Now, even if we don't get selected for that, we still intend to develop the New Glenn vehicle, which is what we're trying to get contracts for. And we've already signed up a number of satellite payload customers who want to fly their payloads on New Glenn. And one of the reasons for that is one of our key differentiators is the payload fairing on New Glenn is a 7-meter diameter. And the audience probably doesn't know a whole lot about satellite technology today, but there's all of these very large deployable antennas and deployable solar arrays. And in order to fit inside a launch vehicle cylinder, you have to pack it up like origami. And you have all these delicate mechanisms that have to function perfectly, or else you lose the economic value of the satellite. And so having a significantly larger payload fairing diameter is allowing satellite manufacturers to have an easier time designing satellites and pack more of them in there and get better value for their money.
So I have a question.
Yes.
So it seems like landing vertically has got to be, there's a significant control problem there, sort of like a souped up inverted pendulum.
Yes.
And you probably have to do sophisticated planning and update that real time. How much compute do you have on board, or do you just do it on the cloud on AWS? That's a joke.
We do use a lot of AWS, but not for flight. We do a lot of computational fluid dynamics stuff in the cloud. During flight, we only need roughly the equivalent of a standard Intel processor to run the algorithms needed to do the landing. So if you've ever tried taking a pen and hold it in your hand, inverted pendulum, it's very difficult to keep it upright. If you try it with a broom, it tends to fall over more slowly, and so it's a lot easier to hold a broom up. When you have a 60-foot rocket, it moves out much more slowly because it's larger, and so the update rate isn't that terrible.